Hello, I will talk about special relativity. There are three phenomena that occurs when someone is traveling at very high speed, close to the speed of light. The first phenomenon is the increase in mass. The second phenomenon is length contraction. And the third phenomenon is time dilation. I will start with the increase in mass. Suppose the twin brother who goes on a journey in space weighs 98 kilograms. So his mass will be 10 kilograms. According to the simple equation of weight equals to the mass times the gravity on Earth. The gravity on Earth equals to 9.8 meters per second squared. And so the weight equals to the mass times the gravity. His weight is 98 kilograms. And when we divide it by the gravity on Earth, we get his mass. So his mass on Earth is 10 kilograms. Okay? I will explain the meaning of G equals to 9.8 meters per second squared. If you drop an object from the roof of a high-rise building, the velocity of the object will be 9.8 meters per second in the first second. In the second second, its velocity will be twice as its velocity in the first second, and it will be 90.6 meters per second. In the third second, its velocity will be 3 times more than its velocity in the first second, and it will be 29.3 meters per second, and so forth. In the 10th second, its velocity will be 98 meters per second. In conclusion, every second the velocity of the object will increase by 9.8 meters per second. So when it will move in the spaceship at a speed of 80% of the speed of light, that is 240,000 kilometers per second, according to the mass increase equation of special relativity, his mass in space will be about 16.33 kilograms, but he will not feel it. I will explain first of all the equation of mass increase. M is the mass of the object or the twin brother that travels in space at very high speed. M naught is the rest mass, or the mass of the object or the man on Earth when he or it is not moving at all, and we divide it by the root of 1 minus v squared divided by c squared. V is the velocity of the object or the man that is traveling in space at very high speed. So in our example, m naught equals to 10 kilograms, the weight of the twin brother on Earth, and we divide it by the root of his velocity in the spaceship, that is 240,000 kilometers per second, and we square it, and we divide it by the speed of light squared, and we get the result of 16.33 kilograms. So actually his mass has been increased by 63.3 kilograms. His mass has been increased by 63.33%, from 10 kilograms to 16.33 kilograms. But he himself will not feel it, and if his twin brother has a mass detector, then the detector will measure 16.33 kilograms. That means that his mass has increased by 6.33 kilograms. Now I will talk about the second phenomenon that occurs when someone travels at space at very high speed. The phenomenon is length contraction, or shortening the distance. When you measure a distance between two objects that are not in motion relative to each other, let's assume that you measured a certain distance. So that distance between them will shrink when one of them moves at a speed very close to the speed of light relative to the other. So I will explain the equation of length contraction, or shortening the distance. L is the distance between two objects when one of the objects is moving towards the other object at very high speed. L naught is the distance between the two objects when they are not moving relative to each other, and we multiply it by the root of 1 minus v squared divided by c squared. V is the velocity of the object that is moving towards the other object, and we square it and we divide it by the speed of light squared. So in our example, the distance between Earth and the star epsilon was 10 light years, and when we multiply it by the root of the velocity, 1 minus the velocity of the spaceship that moves towards the star epsilon and squared, and we divide it by the speed of light squared, we get that the distance between Earth and the star epsilon have been shrunk to 6 light years only, from 10 light years to 6 light years only. So you should remember that our sun is not moving relative to the star epsilon, because the sun and the star epsilon move as one unit around the center of the galaxy, but the distance between them doesn't change. Suppose that my thumb is the solar system and my finger is the star epsilon, and my fist is the center of our galaxy, the center of the Milky Way. So the solar system and the star epsilon revolve around the center of our galaxy, the Milky Way, as one unit. So the distance between them doesn't change. The distance between the solar system and the star epsilon doesn't change because they are moving as one unit around the center of our galaxy, the center of Milky Way. Okay, so the distance between Earth and the star epsilon, when you measure it from Earth, the distance is 10 light years, because in that situation the distance between our sun and the star epsilon doesn't change, and in that situation the distance is 10 light years. But when you measure the distance from the spaceship that moves in space at a speed of 240,000 kilometers per second, then the distance will be shrunk to 6 light years only, from the point of view of the twin brother flying in the spaceship. So when the twin brother is moving towards the star epsilon at a speed of 240,000 kilometers per second, then the distance between Earth and the star epsilon will shrink to 6 light years, from 10 light years to 6 light years only. So I will repeat again on the equation: L equals to N naught times root of 1 minus V squared divided by C squared. So L is the distance between the two objects when one of the objects is moving towards the other object at very high speed. And N naught is the distance between that two objects when they are not moving relative to each other. Okay, and we multiply it by the root of the velocity of the object that is moving towards the other object. We square it and we divide it by the speed of light squared. And in our example, the velocity between Earth and the star epsilon as I've already said, will shrink from 10 light years to 6 light years only. Okay, but in addition to that, the height of the man in the spaceship also shrinks, and if on Earth his height is 1.8 meters, then from the point of view of the twin brother who remains on Earth, the height of the twin brother in the spacecraft shrinks to only 1.8 meters. So I will explain the equation. Actually, it is the same equation that we use for distance shortening between two objects. In that now we use the same equation in order to calculate length contraction, the contraction of the height of the man or the object that travels in space at very high speed. So L is the height of the object or the twin brother that travels in space at very high speed, and L naught is the height of the object or the twin brother on Earth, and we multiply it by the root of 1 minus v squared divided by c squared. V is the velocity of the object or the twin brother that is traveling in space at very high speed. We square it and we divided it by the speed of light squared. So in our example, the velocity of the twin the height of the twin brother is 1.8 meters on Earth. Yes, it is L naught, and it is his height on Earth is 1.8 meters, and we multiply it by the root of 1 minus the velocity of the spaceship that is on it and moves towards the star epsilon. We square it and we divide it by the speed of light squared. So, and we get the result of 1.08 meters. So we see that the height of the twin brother shrinked from 1.8 meters to 1.08 meters only. So when someone or something is traveling in space at very high speed, it will be shorter. The object or the man that travels in space at very high speed, it will be shorter. In our example, the height of the twin brother has been shortened from 1.8 meters to 1.08 meters only, so is shorter by 72 centimeters when is traveling in the spaceship at a speed of 240,000 kilometers per second. Okay, so Uh, in conclusion, we can say that equation actually describes two phenomena. The second phenomenon is the shortening of distance between two objects when one of the object is moving towards the other object at very high speed. And the second phenomenon is the shortening of length or shortening the height of the object or the twin brother in our example. So we finished with that phenomenon, and now I will talk about the third phenomenon that occurs when someone is traveling at very high speed in the space. The third phenomenon is time dilation. As mentioned, from the point of view of the brother who is on Earth, his twin brother is moving in the spaceship at very high speed. Therefore, the rate of time flow in the spaceship will be slower than the rate of time flow on Earth. While on Earth it took 25 years for the twin brother to return from a journey in space, in the spaceship the total time that it passed is 15 years only. So I will explain the equation for time dilation. T is the total time that is passed in the spaceship that travels at very high speed, equals to T naught. T naught is the total time that is passed on Earth during the journey, and we multiply it by the root of 1 minus v squared divided by c squared. V is the velocity of the spaceship. We square it and we divide it by the speed of light squared. So in our example, the total time that is passed on Earth during the journey from Earth to the star Epsilon and back to Earth is 25 years, and we multiply it by the root of 1 minus the speed of light squared divided the speed of the spaceship divided by the speed of light squared, the speed of the spaceship squared divided by the speed of light squared. And actually the velocity of the spaceship is 240,000 kilometers per second, and when we divided it by the speed of light, that is 300,000 kilometers per second, we get 0.8 and squared, and the root of 1.08 squared is 0.36, and the root of 0.36 is 0.6. 0.6 times 25 is 15 years. So the total time that is passed in the spaceship is 15 years only. And the reason for it is because of the fact that the rate of the time flow in the spaceship is slower than the rate of time flow on Earth. And that phenomenon is called time dilation. So the brother the twin brother in the spaceship will be 10 years younger than the brother that stayed on Earth. Okay, that is from the point of view of the brother that stayed on Earth, because he sees his brother that travels at very high speed in the spaceship, and that is the reason that there will be a time dilation. Okay? While from the point of view of the twin brother who embarked on a space journey towards the Epsilon star, he is at rest and the Epsilon star is moving towards him at a speed of 240,000 kilometers per second. Therefore, in this situation, there will be a contraction of distance according to special relativity. And the total distance between Earth and the star Epsilon will be 6 light years only, and the round trip distance is 12 light years, and at a speed of 80% of the speed of light, the entire journey in a spacecraft will take 15 years due to the contraction of the distance between the spaceship and the star Epsilon. So, from the point of view of the brother that is in the spaceship, he is at rest and the star Epsilon is moving towards him at a speed of 240,000 kilometers per second, and in this situation there will be a contraction of distance between him and the star Epsilon, and the distance between them will be no more 10 light years but 6 light years. So the round trip back and forth will be 12 light years, and at the speed of 80% of the speed of light, the total time that is passed is 15 years only. So we see that the two brothers actually agree that the total time that is passed in the spaceship is 15 years only. Okay, thank you very much.